The internet has revolutionized the way Americans process information. Social media platforms such as Facebook and Twitter have become a tool in which citizens can express their thoughts and feelings in response to current events. However, as the country has grown more and more polarized over certain issues, the presence of hate speech has also been shown to increase. Given the relationship between politically charged rhetoric and hate speech, we seek to determine whether this relationship can be observed through transfer learning. In this paper, we study the effect of pre-training on partisan/non-partisan political tweets for a hate speech classification model. We hypothesize that pre-trained parameters from a partisan classification problem will perform better in a hate speech classification problem than randomly initialized parameters.
We used two datasets. The social media political bias dataset from Crowdflower includes 5,000 messages from Facebook and Twitter accounts of U.S. politicians labeled as partisan or nonpartisan with a 26 to 74 partisan to neutral split. Likewise, the hate speech dataset includes 5,593 tweets labeled as hateful or neutral with a 26 to 74 hateful to neutral split.
So in order to investigate our research question, what we did is we designed 5 primary models in order to isolate the relationship between political bias and hate speech. These 5 models were transfer learning from the political bias to hate speech for both the LSTM and GRU, as well as random initializations for LSTM and GRU, and we also had a baseline control model. We ran these models and recorded the results.
Right, so just to briefly cover model architecture, we wanted to use some form of recurrent architecture given that this was a many-to-one problem, and so we adapted our model architecture from a paper written by Yenter and Verma. And the defining characteristic of this architecture is that it uses 4 branches. So in each branch, there's a conv layer, followed by a ReLU activation, followed by a max pooling layer, followed by a dropout, followed by a batch norm, and followed by some recurrent layer. So in their case, they used an LSTM. We tried both an LSTM and a GRU. And additionally, we tried a bag of words model, so essentially just representing text as a collection of all of its constituent words and then feeding that into a naive Bayes classifier. This was used as our baseline for comparison to our neural network-based models.
In all of the LSTM and GRU models, we implemented early stopping, which would happen in cases where the loss hasn't decreased for 2 consecutive epochs. As you can see in the graphs on the left, with the transfer learning models, this occurred much earlier when compared to the random initialization models. This sentiment was also echoed in our analysis of the area under the ROC curve. As you can see in the graph on the right, we observed the transfer learning models performed worse than the baseline, whereas the random initialization models performed better than the baseline. There was some variation in the performance of LSTM versus GRU, where LSTM performed worse in the transfer learning models, but better in the random initialization models.
Based on our results, our initial hypothesis appears to be false, which leads us to believe that the relationship between partisan tweets and hate speech is not as strong as we thought. However, there are 2 potential falsifiers we should discuss. The first is that hate speech identification is somewhat subjective. What one thinks is hate speech, another might think as just offensive language. Therefore, when we compare 2 hate speech classifiers, we can't objectively say that one is doing a better job than the other because they might be simply using a different discretion boundary. So when evaluating our network's performance, we need to take the raw results with a grain of salt. The second issue is our insufficient amount of data. As neural networks scale with the amount of data available to them, perhaps if we had more available data, our results would differ.
Future work includes 1. Gathering more data to better train and evaluate our neural network. 2. Conducting a survey or other human experiments to get a better sense of where the Bayes error lies within a particular cultural community, such as American college students. And 3. Gathering social media posts labeled as conservative, liberal, or neutral, rather than partisan or nonpartisan, and explore the transfer relationship between the political spectrum and hate speech.